Hey everybody, Mr. Grove here. Today we're going to talk about some more protists. And so we've kind of already checked off some individual protists in kind of our protist kingdom family tree. We talked about the diplomonads first with Giardia, and then we talked about the Euglena. And today we are going to talk about the Dinoflagellates. And so that'll be our first one. And so the Dinoflagellates are protists, and they've got two flagella, and they've kind of got this circumferential groove as across their equator. So these are single cells. These are going to be protozoan, so they're animal-like, although they often are kind of misspoken as algae-like because of their reddish color, but they definitely act like animals, and they consume oxygen. They're also going to give off a little bit of a mild toxin, and so that becomes a problem for wildlife that can consume that. So like mollusks and shellfish will consume the red tide protists, the Gonalaux, and then as they accumulate that, then when things eat the shellfish, then they can get more and more toxin, and so it concentrates as it goes up the food chain, and oftentimes can kill quite large mammals, including humans, if they aren't careful. So the specific one that we're talking about is Gonalaux, and we often just kind of call that the red tide. Particularly, one of the things that is a component of them having their blooms is if we have a lot of heat, so the temperatures are warm, and then maybe a lot of rain that can kind of cause this fertilizer runoff. And so, you know, most of our Midwest, our fertilizer runs off, eventually makes it to the Mississippi and down into the Gulf of Mexico. And so the Gulf area has a lot of potential red tides. And in fact, as we can see over here, one of our universities in Alabama, a football powerhouse, is the Alabama Crimson Tide. And so that's where that comes from. You know, who would have thought that major football powerhouse would be the mighty protist, but that is what it is. Economically, though, is where humans really get tagged. We've got, you know, most people are not going to swim in something that looks like this, but if you own a restaurant or you own a tire shop or something in a town that's a tourist beach town, and your beach gets closed due to a red tide for 3 weeks, and that means 3 weeks of tourism that's not coming your way. So it can have a really strong economic impact. And in other areas of the world for fishing. So if your fish are in a red tide area, then they're not consumable. And so your fishing industry then gets crippled from that. So that's the Dinoflagellates, and specifically Gonalaux for the red tides. The next one that we'll talk about is one of our most dangerous organisms on Earth. And so we've got, you know, several of our scary, dangerous organisms here. So we'll start with our great white shark. If you've ever seen the movie Jaws, you know how terrifying they can be. And there are still people today that are attacked and killed every year due to shark attacks. Another scary, scary animal is the black widow spider. So in our area in Illinois, it's probably the most poisonous spider and can have enough venom to kill a human. The T-Rex, you know, if you remember in Jurassic Park, lots of people were eaten by the T-Rex, so very scary. African lions, also extremely scary. If you've ever seen the movie Ghost in the Darkness, that's the true story about the man-eating lion back in the British Railroad days of Africa in the 1800s. And so, you know, very scary potential to be, you know, mauled by a big 300-pound lion. Another dangerous to human organism is this one over here. That is the death angel, Ammonitis, and just a few bites of that would kill you. So all of these are really, really scary, but the most menacing of all organisms on Earth to humans are going to be these mysterious purple dots. And, you know, that is the intimidating purple dots that is definitely the worst. And that's going to be the Plasmodium protist, and that's the protist that causes malaria. So let's take a look at that in a little closer fashion. So the group is going to be the apicomplexians, and so the apicomplexians will be what causes malaria, and the specific protist that we're talking about is Plasmodium. And so the life cycle is kind of a classic life cycle, another double host with mosquito and human. But it's definitely worth talking about because this is the #1 killer year in, year out in the world of any organism out there. So more people die from malaria than any other thing. And so the way it works is the mosquito will take a bite and suck some blood from somebody with malaria, and they will bring in the gametes, okay, so kind of the sperm and egg equivalent. And inside the mosquito is where fertilization takes place. And so once we get a zygote, we're now diploid, and almost immediately that goes back through meiosis to form these cysts to where sporozoites are formed. And so these are these little miniature kind of worm-like things. And so when the mosquito that has the malaria will bite somebody without, it will inject that anticoagulant into their body, and so that causes the sporozoites to go inside the human body. They almost immediately go to the liver, and once in the liver cell, they will start to form merozoites. At this stage is where usually we'll get sick for a small time period, maybe a day or so. Your body kind of knocks it back with its immune system. But while these merozoites are being formed, there's a slight recovery. But then when they bust out and start attacking the red blood cells, that's when it is really dangerous. And so once the merozoites start to attack, that's when we get our traditional super high fevers, shakes and chills and things like that. And so you are definitely, the last thing you're thinking about is swatting mosquitoes. And so you are an easy target for another mosquito, an Anopheles mosquito, to come and bite you. So that is kind of the life cycle. One of the drugs that we use for anti-malaria is chloroquine. And that was kind of an interesting story because as COVID started up, this was one of our first attempts to kind of keep COVID treatment in check. And so we used this a lot, and it almost worked, but not quite. So the levels that we had to use of the chloroquine were too high to really, it was working against the COVID somewhat, but it was also creating some severe side effects. So some of the doctors that I know, they said that we thought it would work, but we're kind of seeing now that there were some kind of side effects, and we kind of wish we hadn't have used it as much as we did early on. So it was a good try. It was a cheap drug. If it would have worked, it would have been amazing. But we still use it for malaria because we don't have to use quite the concentrations as what we were using for COVID. And it's really cheap. So it's about $1 to treat somebody. And so the people that get malaria in the world are well over 200 million a year, but the people that die are down around 1 million. So I mean, you're talking a significant 0.5% fatality rate of who gets it. So that is malaria, and that's the Plasmodium protist that causes that. A couple other quick protists. So we have our ciliates. So ciliates are going to be protists with cilia, and so cilia are different from flagella because they are kind of all around small hair-like fibers that will kind of beat back and forth to either move the protist or move the water around the protist. Flagella are usually just one or two longer tails that do that. And so the classic protist that's a ciliate that we kind of usually refer to as the Paramecium. So Paramecium kind of have this oval shape, and they can go through conjugation, so they'll line up, the oral grooves will exchange these little micronuclei that have DNA, and that's basically the definition of sexual reproduction, when you exchange genetic information. So Paramecium are not harmful in any way. They're very common freshwater. and just part of the food chain, and so they're definitely a good guy protist. One last one, and this is going to be our amoeba. So sometimes we call the amoeba group the rhizopods, and amoeba have these pseudopods, or the cytoplasmic extension, sometimes called false feet. So that's what pseudopod literally means, pseudo false pod feet. And so they will do this cytoplasmic streaming where they push out their cytoplasm and just kind of engulf the little whatever protist they're trying to meet. And so they are kind of the big and bad bullies of the little microscopic protist world, kind of the Jabba the Hutts, if you will. And they are predators on other protists. And so that is the amoeba. And one specific kind of amoeba is Entamoeba histolytica. And so this is the amoeba that causes amoebic dysentery. And that is definitely a disease that is prevalent throughout the world. If malaria is the #1 killer, gold medal killer winner every year, hands down, no one's even close second, then amoebic dysentery is the silver medal winner every year. So the second most people that are killed year in, year out are usually by amoebic dysentery. And so impoverished areas with poor sanitation and drinking water is who are going to be at risk for this. And it's a real problem. And so, we joke about saying stay safe from protists by not drinking poopy water, but it's really true in that aspect, because contaminated drinking water is one of the main transfers of amoebic dysentery. So those are some more of our protists, and that kind of rounds out the protozoans, the animal-like ones. And next time we'll kind of move on to the fungus-like. So I hope that was helpful.